In the first scenario, the participant was presented with two options. Option 1, either 1 million euros guaranteed, or option 2, having a 10% chance of winning 5 million euros, 89% chance of winning 1 million euros, and a 1% chance of winning nothing. In scenario 2, the participant was presented with again two options. Either 11% chance of winning 1 million euros and 89% chance of winning nothing. And the other option was a 10% chance of winning 5 million euros and 90% chance of winning nothing. The participant will choose option A1 in scenario 1, as a win of 1 million euros is guaranteed and thus a safe option to choose. Consequently, if option A1 was preferred over B1 in the first scenario, then option A2 must be preferred over B2. This way, the expected utility in both cases remains the same, which is in line with the independence axiom. It states that two lotteries with the same difference in expected utility should also yield the same preference, which means in this case they should stick to either A1 and A2 or B1 and B2. To make this more accessible, let's look at it in numbers. If a participant has a preference for winning $1 million, which is 100% safe, over winning 5 million euros with only 10% probability, then they should also prefer 1 million euros with an 11% probability of winning over winning 5 million euros with a 10% probability.
In scenario 1, if we decompose the probabilities of option A, we will see 11% chance of winning 1 million and the 89% of chance of winning 1 million. When we do this for scenario 2, we see the same situation. 89% chance of winning 1 million is replaced by 89% chance of winning nothing. Therefore, if it compared to option B, option A1 is the same as option A2. So if one chooses option A1, following the expected utility theory, he must choose option A2. However, option B seems more favorable. This can be explained using the Elias paradox. The Elias paradox shows that one of the main pillars of the EUT, namely the independence axiom, has clear flaws. This axiom tells us that there are choices that should not be influenced by frames and thus should be the same in different situations. Or, in this situation, one should stay loyal to their choice in the first question. Yet people are clearly influenced by the framing and thus change their choice, which violates the independence axiom. Concluding this experiment, we can say that the independence axiom and thus the expected utility theory too can be refuted with the Elias paradox. Now that we've seen the hypothesis and the paradox of the first experiment, we will go to the second experiment.
Now we can state the hypothesis of the second experiment. People tend to be risk-averse. This also explains the answer for the first scenario in experiment 2. Individuals will prefer to choose option A1 because they knew at least there was a 50% chance of receiving 10 euros, while option B1 the percentages were unknown. But if we choose for A1, it means we would also have to choose for B2. This has to do with independence, as we need a subjective belief about the composition of red and blue balls in urn Y. Either that there are more or less blue balls in urn Y compared to urn X. Therefore, if the participant chooses A1, they would have to choose B2.
So now that we've seen the hypothesis for experiment 2, we can get into the paradox connected to experiment 2, which is the Ellsberg paradox. First, to revise the options, option A1 and B1 were first a 50-50% chance and an unknown chance, which was also repeated in option A2 and B2. Yet, either for the first one you could win 10 euros for the red ball, and in the second one you could win 10 euros for a blue ball. People, according to the expected utility theory, would therefore first answer option A1, as explained in the video, and after that they would choose B2. But people usually tend to answer option A1 and A2. This contradicts the expected utility theory, as the independence axiom stated that two lotteries with the same difference yield the same preference. In this case, the expected utility was the same in both lotteries, and a rational person prefers either the higher or lower probability and then sticks with this. But in this case, there was a clear violation of the independence axiom, as choosing A1 and A2 is inconsistent with any subjective belief about the composition in urn Y. We can also say that people dislike the added uncertainty about risks, or saying it in other words, we prefer the known unknowns to the unknown unknowns. Concluding, we can say that the expected utility theory is flawed. This is both proven by the Elias paradox and the Ellsberg paradox. The independence axiom is violated in both cases. We can also say that people dislike the added uncertainty about risk. This was proven by the Ellsberg paradox. Therefore, we need to adopt different theories that include these paradoxes. One example of these theories is the prospect theory. Now, thank you very much for watching this video, and we will now move on to the class.